A very good afternoon to you, my dear learner and viewers out there. Welcome to this edition of our lessons here on UBC TV. My name is Eric Picho. I teach physics at Kololo Senior Secondary School. I'd like to welcome you to this lesson. Today, we are in Senior 3, and the topic we are going to be discussing is linear motion. But before we go there, COVID-19 is still here. I'd like to thank you for keeping yourselves safe. The fact that you're still able to sit out there and attend to these lessons is a testimony that you've kept yourself safe, and I can't take that for granted. Thank you for keeping yourself safe. Let's continue keeping ourselves safe. Let us continue following these guidelines. Even after COVID-19 is over, these health guidelines are good for us. Let's continue observing them so we may stay healthy. Now, if you're in Senior 3, please pick your notebook and calculator and your pen and move closer to your set, because we are going to discuss linear motion. Now, this is our expectation at the end of this lesson today. I expect that at the end of this lesson, you will be able to define linear motion. At the end of this lesson, you should be able to define some terms involved in linear motion. At the end of this lesson, you should be able to do some simple calculations involving speed, acceleration, time, some simple calculations you will be able to perform at the end of this lesson. So please, let's keep together, let's follow through, and let's be attentive. Now, motion. You have done a lot of motion today. Did you know that? Before we get into understanding what linear motion is, it is very important that we understand what motion is. Today, you woke up in the morning, moved from your bedroom to the sitting room, moved from the sitting room to probably outside, then came back inside. All that is motion. Motion, in simple terms, is the act of changing position. The act of changing position. When you are in your bedroom, you are in a certain position. When you move from your bedroom and go to the sitting room, you have moved to another position. When you move from the sitting room and you go outside and you come back, you're literally changing position. So when we talk about motion, it is the change in position. I'll put that right here. The act of changing position. That is motion, the act of changing position. Now, if you are moving and the movement is along a straight line, we then call that linear motion. During that process of changing position, if you're moving and your movement is along a straight line, we call that linear motion. So how would we define linear motion, therefore, as? Linear motion is the movement along a straight line. So linear motion Okay? Linear motion is the movement along a straight line. Take note, I have said that motion itself is the act of changing position. You move from position A, go to another position B, you go to position 3. That we call motion, the act of changing position. But during the process of changing position, this movement can be along a straight line. And what we are saying is that if the movement is along a straight line, we call that linear motion. Take note that the word linear actually comes from line, right? The word linear comes from line. So if we talk about linear motion, it is the movement along a straight line. Very important. The other thing I need to highlight, which is also key to understand, is that this linear motion can be horizontal, but it can also be vertical. I'm going to give you some scenarios, some examples of when the linear motion is horizontal and when the linear motion is vertical. I actually know that as we speak, you're thinking about some examples already. Okay? Now, take note, we are saying that linear motion can be horizontal or vertical. So it can be horizontal or vertical. Okay? Linear motion can be horizontal or it can be vertical. I need to give you this scenario. Some of you are athletes, I know. When you're taking a 100-meter race, you're running 100 meters. You can bear with me that this running is along a straight track. Okay? You run in a straight line when you're taking a 100-meter race, right? But you're running on a horizontal or in a horizontal direction, right? In other words, you are running in this direction. So this one we call horizontal. Okay? But because you're running in a straight line, that is called a horizontal linear motion. Okay? I can give you another example. If you're riding a bicycle, okay, and you're riding along a straight line, that one is a horizontal linear motion. There is no one who rides a bicycle while moving upwards. Is there anyone who does that? It's not there. So each time you're riding a bicycle, you're riding horizontally. So we call that horizontal linear motion. If you're driving horizontally, we all drive horizontally. You cannot drive vertically. That is called a horizontal linear motion. Okay? Very good. Now, we have explained what horizontal linear motion means. But then, we are saying that this linear motion can also be vertical. The linear motion can also be vertical. Okay? Do you know how? Or do you think of, are you thinking about how it can be vertical? Think about it. Get a pen, the pen that you have, or the pencil that you have. Throw it upwards. What happens? When you throw this pen vertically upwards, it moves, but of course eventually it comes back down. We call that a vertical linear motion. Why is it vertical? Because this time the pen is not moving horizontally, but it is now moving vertically. Okay? This time the pen is now not moving horizontally, but it is moving vertically. But the fact that this pen still moves in a straight line, we call that a vertical linear motion. Are we together? Very good. Now, think of a fruit, a mango, an apple, whatever, which is falling from a tree. Is that horizontal linear motion or vertical linear motion, if I may ask? Definitely, that is a vertical linear motion, because when this fruit is falling from a tree, it falls downwards. It does not move horizontally. And that is why we call that a vertical linear motion. Very good. So at this point, we know that linear motion can be vertical. It can also be horizontal. We have other types of motion. We are not going to discuss them here because our focus is on linear motion. Okay? We have things like circular motion. Okay? Circular motion is there. You will get to know what circular motion is at a later time. Today our focus is linear motion. So we have said linear motion is the movement of a body along a straight line. Linear motion can be horizontal. It can also be vertical. And I have given you some examples. Good. Now, the next thing we want to discuss is some terms. Some terms. You see, each time a body is moving, there is a certain distance it is covering. There is a time this body takes to cover that particular distance. There is a speed at which this body is moving. Those are some of the terms that we want to get to understand what exactly they mean. I know some of you have met these terms, okay? Actually, some of the terms, you have used them before. For example, distance, okay? Speed. These are not really new terms, right? But as you're going to notice, there are some terms that we are going to introduce that you might be hearing for the first time, that might be new to you. We are going to talk about a term like acceleration, okay? Acceleration. We are going to talk about deceleration. What exactly does this mean as far as motion is concerned? You might have heard this before, but maybe you don't exactly understand what this term is. So we are going to be able to discuss that. So let's go right to the terms. Some terms used in motion. Some terms in motion. The very first term we are going to begin with is the obvious one, the one that you know, okay? Distance. Distance, this is S. Distance as a term. I'm going to ask you about this because at least I'm very sure this term you have used it quite a number of times, okay? So what is distance? What is distance? Correct. The length between 2 points. The length between two points. And really, this definition is self-explanatory. If we have a point A here, okay, this is point A, then we have another point B somewhere there, okay? So we are saying the length between this point A and the other point B is what we call distance. So if we measured from here up to that point, this is what we call distance, okay? So this is point A, somewhere here, then we have point B is somewhere there. So we are saying the length in between those points is what we call distance, right? Very good. Now, it is not enough for us to know what distance is. We need to know the unit, the SI unit of distance. And again, here I know you know this from, primary school, senior one, where you discussed about different quantities and their units. So the SI unit is the meter. And we represent that with small m. That is the SI unit of distance. But take note that this is not the only unit of distance. There are other units of distance, of course. We have kilometers. Do you know them? Kilometers, centimeters, millimeters, and so on. All those are other units of distance. But we want to focus on the SI unit, which is meter. Good. Another term that we want to look at, which is very, very closely related to distance, is a term called displacement. Displacement. It is a term that we are going to really use quite oftenly in this area of motion. Now, this term, I need you to be very, very attentive here. These terms are related, but not exactly the same. I'll first define displacement, okay, and then I explain how these two are different. What is displacement? Displacement is the distance covered in a specific direction. The distance covered in a specific direction. The distance covered in a specific direction. That is how we define displacement. Now, listen to this explanation. How is displacement different from distance? When we talk about displacement, the direction, displacement also is movement. It is actually length, okay? But the difference between displacement and distance is that for displacement, there's got to be a specific direction in which you are moving, okay? Distance, if I say, for example, move a distance of 2 steps. If I gave you an instruction and I said, move a distance of 2 steps, you can either move forward 1, 2. You have moved the distance. If I gave you the same instruction, move a distance of 2 steps, the one who is going to move to his right-hand side 2 steps is also correct. Okay? Someone could move on the right-hand side 2 steps, 1, 2. That person is also correct. If I said move a distance of 2 steps and you moved backwards, you're also correct. Are we together? Good. Now, how is it different from displacement? If I say displace yourself 2 steps, then for you, you move 2 steps forward. I'll ask you a question. How did you know that I wanted you to move forward? What if I wanted you to move backwards? What if I wanted you to move to the right? What if I wanted you to move to the left? I don't know if you're getting the point here. So displacement, the aspect of direction is very, very important. So if I say displace yourself 2 steps, I need to clearly tell you the direction in which I want you to displace yourself. Okay? So the correct instruction would be displace yourself 2 steps to the right, then you will go to the right. Or I would say displace yourself 2 steps backwards, then you would go backwards. That would be the correct instruction. So for displacement, it is not just about any distance. Okay? It is not just about the distance moved, but we are saying rather the direction in which the distance is moved. That is very, very important, my dear learners. Okay? So very good. So I hope you have now understood why we say displacement is the distance covered, but in a specific direction. This is very important, in a specific direction. Now, the SI unit of displacement is also meter. Okay? Remember, displacement it is actually about moving a certain distance, only that this time you're moving in a specific direction. Okay, so SI unit is meter, which is also m, right? Good. Let us talk about another term, speed. Speed. This you're very familiar with. Very, I know. What is speed? Right? Speed. How would you define speed? I know you're defining it out there wherever you are. Okay? Speed is the rate of distance covered. Okay? The rate of distance covered. Or it is the distance covered in a specific, per unit time. The distance covered per unit time. Let's write that definition down. The distance covered per unit time. That is speed, the distance covered per unit time. Or the rate of distance covered. Now I need to explain something here, very important. When you look at the first definition, we are talking about speed as the distance covered per unit time. Okay? The distance covered per unit time. We look at the distance you have covered and the time you have taken to cover that distance. When we do that, we shall be talking about the speed. Are we together? If you're covering a distance of 100 meter, you're running 100 meter, right? Then we shall ask ourselves, how long have you taken to run the 100 meter? Okay? If you have taken 5 minutes to run 100 meter, then we can calculate your speed by getting the 100 meter and we divide by the time you have taken to run the 100 meter. That gives us speed. But the point I wanted to highlight here, very important, is in these two definitions, and I need you to take note of this. When we define speed as the distance covered per unit time, we are saying we can also define it as the rate of distance covered. Now, the moment you mention this rate of distance covered, don't talk about time now. The mistake I see with students sometimes, you say the rate of distance covered per unit time. That is wrong, okay? The moment you have mentioned rate, this rate already implies the unit time, okay? So you don't say the rate of distance covered per unit time. You will be doing a repetition, right? So it is the rate of distance covered. If you want to talk about time, then don't bring rate, use the first definition, okay? The distance covered per unit time. If you're using rate, then don't add here the rate of distance covered. If you say here, per unit time, okay? This one here we are saying is wrong because when you say per unit time, you are now repeating the word rate. Rate actually means out of time. I don't know if that is, you get what I'm trying to say here. So either say speed is the distance covered per unit time, or simply the rate of distance covered. I prefer the second definition, it's shorter, the rate of distance covered. So I hope you've taken note of that, and please don't make that mistake. Now, when we say the rate of distance covered, mathematically, what does this mean? Okay, I told you we can be able to calculate speed. If you have taken a 100 meter race, okay, we can calculate the speed at which you have taken that race, the speed at which you have run. How do we do that? We get the 100 meters that you have run, and then we divide that by the time taken, okay? So speed is actually equal to the distance covered okay? Distance covered out of time. Distance covered out of time taken. That is how we calculate speed. The distance covered out of time taken. Now, what about the unit of speed? We can get the unit of speed right from this formula, the formula that you have written. And pay attention. I know you know. People are already saying the unit is meter per second. Very correct. Okay? So we know that the distance covered, remember we talked about distance and we said the unit of distance is meter, right? So here, the unit up there is meter, okay? Out of time taken, what is the SI unit of time? Senior one, we know it is seconds, okay? In terms of units, we have meter up, we have second down, right? So this is what we actually call meter per second, okay? This is what we call meter per second. Now, meter per second can also be written as ms to the power negative 1. Ms to the power negative 1. And of course, there is a way it comes about. This is mathematics indices. Remember, this s is to the power 1. This s is to the power 1. And in mathematics in indices, we know that this s can move from down and it can go up. Now, when s moves from down and it goes up, what happens? The sign of this one changes and it becomes a negative, right? S can move from down and it goes up, okay? Remember, at first we have only m up, okay? But now we want to take this s also up. So when s goes up, we are going to have m, s, but the power now does not remain positive. The power changes to a negative. So this becomes negative 1. And that is how this one here comes about. That is indices in mathematics. Okay? So the unit of speed is meters per second. Now, there are other units. Kilometer per hour is there. It's a very common unit. Actually, I'm going to be giving you some exercise at the end of this lesson, which involves kilometer per hour. I want to see how you're going to go about that conversion. But for now, this is the unit of speed, okay? So we shall put here that SI unit is meter per second, okay? But we have other units like kilometers per hour. Good. I hope we are moving well so far. Very good. The next term we want to look at, this is very, very important because it is closely related to speed. We call that velocity. I'm very sure this is a new term. Distance, speed, those have not been new really. I'm sure you've met these before. Maybe displacement is new for some of you, but velocity is another new term that we've got to discuss. Velocity. This time I've written it in blue. Velocity. Okay. Well, maybe not to confuse you, let me maintain the color that I've used. Let me maintain the color. So this is velocity. 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 Now, this term velocity is very, very closely related to speed, like I told you earlier, but it is not exactly speed. How do we define velocity? I'm going to define velocity, then I give you an explanation. Velocity is the rate of change of distance covered in a specific direction. The rate of change of distance covered in a specific, let's check our spelling of specific. There is a C, specific, okay? The distance covered in a specific direction. That is how we define velocity. Now remember, we defined speed as the distance covered per unit time, or the rate of distance covered. What do you notice is new here as far as velocity is concerned? There is an aspect of direction which is coming in that was not there in speed, right? Speed is the rate, okay, of distance covered. But we are saying velocity is the rate of change of distance covered in a specific direction. Are you getting the difference here? So we see that something new which is coming in velocity is actually direction. So when it comes to velocity, direction is also important, right? So like we are saying, the rate of change of distance covered in a specific direction. However, I want you to take note of this. We are going to analyze this definition, and then we relate it with one of the terms that we have discussed. I want to go for a break right now, and for me it's basically going to wash my hands. Want to go wash my hands? You can do the same, or grab a glass of water, then we shall come back. Please sanitize. Let's be back. Don't go away.